moving on, we're going to talk about question number 4. So I already wrote out some definitions here because it took me a long time to write out all the definitions. But the question reads, what does it mean to normalize a vector? So we need to talk about a vector first. So a vector is a mathematical object that has a magnitude and a direction. So the convention of writing a vector is usually these pointy brackets and x, y in between. And another way we can write this, so we can set these coordinates, I guess I can say, to a vector, let's say u. So if we insert an equation here, we can say, so this is the arrow, the half arrow at the top indicates that this is a vector and that it has a magnitude and a direction. So these numbers in these brackets signify to us that, oh, there's a magnitude of this vector, and also it signifies its direction. Another thing to note is how to calculate the magnitudes. So calculating a magnitude is you calculate the square root of x squared plus y squared. If you have more coordinates, for example, you have 3-dimensional, you can have 4-dimensional vectors, you would include those inside the square root. So for example, if we had x, y, and z, we would also include plus z squared, right? So this is how you calculate the magnitude of a vector. So what does it mean to normalize a vector? Well, we also need to talk about what a unit vector is. So a unit vector is a subset of any vector that has a magnitude of only 1 and has a direction, right? So normalization is a process of taking a normal vector, let's say vector v, and converting it into a unit vector. And unit vectors are very useful because they tell us the direction of that vector without really being confused by its magnitude. So normalization is a process of transforming a vector to its associated unit vector. And the equation for that is unit vector u equals vector v over magnitude of v. So we're going to do an example, as the junior tutor also does an example, and then we'll show you how to normalize a vector. Okay. All right. So let's say that we have vector v, which equals, let's say, -3, 4. So let's look at what this looks like on the Cartesian plane. Okay, so -3, 4 would be in -3, x is in this on this side, and 4 is on this side. So it's going to be in this quadrant here. Okay, -3, 4 would look like, so let's say this is -3. Oops. -3, and let's say this is 4 up here. So the vector would look like, sorry for my lines, I can't draw straight lines. The vector would look like this. So it's pointing in this direction, it has a magnitude which we are going to calculate now. So let's say we want to normalize this vector. So normalizing this vector, so we're going to set unit vector u equals vector v divided by the magnitude of v. Okay? So we know what our vector v is. And what is the magnitude? The magnitude is going to be the square root of 3 squared plus 4 squared, which equals 9 plus 16 equals 25. Root of 25 is 5. So now we have, okay, so now we're going to take this constant and divide each coordinate by that constant. So now our unit vector is going to be -3 over 5 and 4 over 5. So this is our unit vector. It has magnitude of 1. If we were to calculate this magnitude, it will equal 1. And we know that its direction is pointing in this direction, in the same direction. So our unit vector, in fact, would be like a small subset of this, and it'll be pointing like that. That's our unit vector. U, and let me label v, and this is v. Okay, cool. So that is how you normalize a vector. So the junior tutor, I used the same example as them, and it also provided a very detailed solution. So this is the correct answer to this question. Good job. Okay.